Hi everyone, I am Kumar and this is my project feedback video for predictive forecasting of care load and placement demand developed for the HHS Unaccompanied Alien Children program. In this video, I will explain what the project is about, how I built it, the challenges I faced while working with the data, and what I learned from this project. The HHS Unaccompanied Alien Children program takes care of children who came into government care. Sometimes the number of children increased suddenly because of border situations, government policies, and humanitarian emergencies. The problem was the HHS had a lot of historical data, but they could not predict future demand. Because of this, they had to react only after number of children increased. This could lead overcrowded shelters, overworked staffs, and longer waiting times for the children. My goal was to build forecasting system that could predict how many children would be in HHS care, estimate future discharge and placement demand, and give early warnings to HHS could prepare shelters, medical staff, and case workers in advance. For this project, I used around 720 daily records from January 2023 to December 2025. Before building any model, I spent a lot of time cleaning the data because it was not in a ready used format. The first issue was that dataset had around 450 completely empty rows, so I removed them. The second issue was the dates were stored as a text, like December 21, 2025, and they were arranged from the newest to oldest. I converted them into proper date format and sorted them in a chronological order. The third issue was that main column children in HHS care was stored as a text with commas such as 2484 instead of number. I removed the commas and converted all numeric columns into the correct format. The fourth challenge was the most interesting. At the first, it looked like many daily records were missing, but after checking carefully, I found that program normally reports data only from the Sunday to Thursday. Fridays appeared only few times, and Saturdays were not reported at all. This means those missing days were expected, not actual missing data. Instead of filling all those missing days with fake values, I created reporting schedule that matched the real reporting pattern. I only filled a few small gaps caused by holidays. This helped keep the data accurate, made forecasting more reliable. After cleaning the data, I performed exploratory data analysis to understand trends and weekly patterns. I also checked whether that data was suitable for forecasting using ADF and KPSS tests. Next, I created useful features such as previous day values, rolling averages, not flow between new arrival and discharges, and calendar based features. For forecasting, I compared several models instead of depending on only one model. I tested simple methods like naive forecast and moving average. Statistical model like SARIMA and exponential smoothing, and machine learning models like random forest and gradient boosting. To evaluate the models properly, I used walk forward validation, which is better for time series data than simple trend test splits. I tested forecasts for 1 day, 7 day, and 14 days ahead. Among all models, random forest gave the best results. I achieved around 99% accuracy for predicting care load and around 71% accuracy for predicting discharge demand, which was more difficult because the data was more unpredictable. Finally, I built an interactive Streamlit dashboard. In this dashboard, user can select different forecast periods, compare different models, view confidence intervals, compare care load forecast with the discharge demand forecast. I also added useful performance indicators like forecast accuracy, forecast scalability index, surge lead time, capacity breach probability. This helps decision makers understand the forecast and plan resource more effectively. The biggest lesson I learned from this project was real world data is never perfectly clean. I also learned that filling the missing values without understanding the reason can produce incorrect result. Understanding the actual reporting pattern was one of the most important part of this project. Another important lesson was the walk forward validation is much better than normal trends tests. Split for the time series forecasting because it avoids data leakage and gives more realistic data results. Overall, this project helped me improve my skill, Python, Pandas, time series forecasting, machine learning, feature engineering, model evaluation, and Streamlit dashboard development. So, thank you for watching.